In this video, we're going to be determining whether two lines are parallel, perpendicular, or they're just intersecting lines. So first, we need to decide what is parallel, or what do parallel lines look like. So parallel lines for us, we already know that parallel lines never intersect. Okay, these never touch, never cross. They will always be walking side by side and never cross. So if I look at a picture, I'm going to see that both of my lines are going in the same direction. They're probably a space apart, but they will never cross. This is the symbol we will be using to show that lines are parallel. Now, when you are given two equations, how do you know? What if I get two equations like this? How do I know that the lines are parallel? Well, we have the same slopes when my lines are parallel. So for example, in my first equation, I need to look for slope, which is m. And if you recall, my equation in slope-intercept form is y equals mx plus b. So I'm looking at the number that represents m, which happens to be the 2. So I'm going to write that down. M is equal to 2. In my second equation, I also have to recall y equals mx plus b and look for the number that represents m. In this case, it is also 2. So I'm going to write that down. When I write down my slopes, I have to compare them to see if they are the same. And for this particular example, both slopes are 2. Therefore, these lines are parallel. What about perpendicular lines? Well, perpendicular lines are kind of tricky because sometimes when we look at lines and they're crossing, we could probably make the assumption that they are perpendicular. But what makes perpendicular lines very special is that they intersect to form 90-degree angles. And the symbol we will be using to show that two lines are perpendicular is this one here. Now, when we look at two equations, my slopes are going to be the opposite reciprocals of each other. Now, if this is too confusing for you, you can think of it in terms of opposite means the slopes have different signs. So one is positive, one is negative. And reciprocals means we're going to have a fraction that is flipped in the second slope. So for example, if you have 1/2, if you flip that fraction, it'll be 2/1. Another way you can find out whether your lines are perpendicular is by multiplying the slopes, and whatever you get should be -1. If you get the answer of -1, then you have perpendicular lines. All right, let's get started. Looking at this example here, I have to first identify my slope. And in this case, m is going to be 2. Here, I need to identify the slope again. Here, m is a -1/2. So my question for you is, are they opposite? Is one positive, one negative? Yes. Are they reciprocals of each other? In other words, if I take the first one, and if I made this a fraction, would it be this flipped? Well, I don't know. I know that to make a whole number a fraction, I can put it over 1, right? Now, what happens when I flip 2/1? Whoop. I'm going to get 1/2. How else can I find out whether these two are perpendicular? Well, I can multiply them together. So on the side here, I'm going to say, well, if I have 2/1 and I multiply it by -1/2, what am I going to get? So when I do that, 2 times -1 is -2, and 1 times 2 is 2. And when I divide that, I get -1. So that means these two are perpendicular. All right. Now, here are two equations. By looking at them, you should already kind of see, are they going to be parallel, perpendicular, or just intersecting lines, okay? So for those of us who, by looking at this, we're like, I don't know. Let's graph them and let's see what happens, okay? So I'm going to take the first equation, which is y is equal to half x plus 2. I know that to start graphing, I always start with the y-intercept, which is the constant. So 2 on the y-axis, always vertical line. And then I'm going to use my slope as the rise over run, or my vertical change over horizontal change. The reason I drew an up arrow for the top number and a right arrow for the bottom number is because both of them are positive. So let's follow this pattern. Up 1, to the right 2, up 1, to the right 2. And I can also do the reverse effect of this. So instead of going up and to the right, I can go down and to the left. And it's still going to create the same line. So here's my first line. And now I want to draw the second line. This one, we're going to start at -4 on the y-axis. So I'm going to go down to -4. And now I don't have a rise over run here or vertical change, horizontal change. So I have to create this into a fraction. So all I have to do is put it over 1. Both of my numbers are positive. That means that the top number is going to move in an upward direction and the bottom number is going to move toward the right. So from here, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And you can do that until you run out of space. So I'm going to draw now my second line. Now just by looking at them, do they look parallel? Do they look perpendicular? Or are they just intersecting lines? Well, they just look like intersecting lines, okay? Well, how do I know that? Well, if you take a look at the two lines, it's obvious. They're just crossing each other. But more importantly, look at the slopes. The slope of the first line was a 1/2. And the slope of the second line was 2, or 2 over 1, whatever makes you feel comfortable. These are different. Therefore, they cannot be parallel. However, the first one is a 1/2, and the second one is the reciprocal of the first. But what is the condition for perpendicular lines? To be perpendicular, we must be opposite reciprocals. So that means that my numbers must be different signs. And in this case, both of them are positive. So we cannot be perpendicular, which leaves us with the last option of intersecting. All right, let's try a couple more. Okay, let's try this one. Same idea, we're going to graph. We're going to start at -1 on the y-axis. We're going to follow our slope because -2 is not a fraction. I'm going to make that a fraction, so -2 over 1. That means -2 go down, +1 goes to the right. So I'm going to go down 2 over 1, down 2 over 1. And I can reverse this so that I go up and to the left. Up 2, left 1. Up 2, left 1. Until I run out of space. Draw your line. And now go to your second one. In the second line, we're going to start at 4 on the y-axis. And now I'm going to travel. This is 1 over 2, so both positive, up and to the right. Up and to the right. And I ran out of space, so I can reverse this. Now go down and to the left. Down, left, down, and left. And draw your line. Now, well, we take a look at them. Well, obviously they're not parallel because they are crossing. They are intersecting. But the question is, are they intersecting lines only, or are they perpendicular? Well, let's take a look at their slopes. I have a negative and a positive. And one of the conditions for perpendicular was that they had to have different signs. Now the second one is reciprocals. Is the second one a flipped version of the first? So this one is 2 over 1. If I flip this, do I get 1 over 2? I do. So I think this is probably perpendicular. But I'm going to check it just further by multiplying the two slopes to see if I get a -1. If I multiply -2 times 1, I get -2. 1 times 2 is 2. Divide, I do get that -1. So that means these lines are perpendicular. Okay, one last one. Same idea. We are graphing them, and then we're taking a look to see parallel, perpendicular, or intersecting. So for the first one, we're going to start at +1 on the y-axis. Because my slope is positive, both numbers, I'm going to go up and to the right. So up 1, to the right 4. And I've run out of space, so I'm going to reverse this to down and to the left. So down 1 and then left 4, and draw my line. Now I'm going to graph the second equation. I start at 4 on the y-axis. My slope again is positive, positive top, positive bottom, which means up and to the right. So I'm going to go up 1 to the right 4. And I'm going to reverse the order because I'm out of space. So down and to the left. And draw my line. Okay, now what do you notice? Are they crossing? Are they intersecting? No, they're not. Well, I have to check their slopes. So the slope of the first one was 1 over 4, and the slope of the second was also 1 over 4. These are the same. What do we know about two equations and two lines that have the same slope? They are parallel lines. Well, hopefully this helps you see the differences among parallel lines, perpendicular lines, and just basic intersecting lines. Until next time.